So now we're on to the final part, part B of question 24, and this asks, find the coordinates of the turning points of the curve. So a turning point of a curve is a point at which is a stationary point of a curve, and this is a point where the derivative changes sign, so from positive to negative or from negative to positive. So we're going to have to use dy by dx, and we're looking for a point where dy by dx is equal to 0. So when dy by dx is equal to 0, we have a stationary point, and if x is increased or x is decreased, the dy by dx is either going to go positive or it's going to go negative. So we're going to have to equate this quadratic equation to 0 and then solve for x. So 0 is equal to 6x squared minus 18x plus 12. And since 6, 18 and 12 are all multiples of 6, we can simplify this and still get the same answer. So we can get 0 is equal to x squared, that's 6x divided by 6 is x squared, minus 3x minus 12 divided by 6 is 2, so plus 2. So let's solve here, and we can in fact put this into brackets. We don't necessarily have to use the quadratic formula because we know that there are two numbers where you add them together to get minus 3 and you multiply them together to get 2. And those two numbers are minus 1 and minus 2. So minus 1 plus minus 2 is minus 3, a minus and then another minus, so you get a bigger minus. And minus 1 multiplied by minus 2 is 2. So if you multiply two negatives, as we know, you get a positive. So we can put this into brackets and we get x minus 1 and then x minus 2 is equal to 0. And then we can solve for that. So we get either x is equal to 1 or x is equal to 2. So these are the two x coordinates for the turning points of the curve, but we're asked to give the coordinates. So we need both x values and y values. And to get these y values, what we're going to do is have to put 1 and 2 into the original equation for the curve y. So let's first find the y value for the turning point at x is equal to 1. So let's substitute x into this equation here. So y is equal to 2 times by 1 cubed minus 9 times by 1 squared plus 12 times by 1 minus 1. So we get 2 minus 9 plus 12 minus 1. So 2 minus 9 is minus 7. Minus 7 plus 5 is, minus 7 plus 12 is plus 5. Minus 1 is 4. So the coordinate for the first turning point is 1, 4. And then how about when x is equal to 2? So we have y is equal to 2 multiplied by 2 cubed minus 9 times by 2 squared plus 12 times by 2 minus 1. So we have 2 times by 2 cubed, so that's 2 times by 8, which is 16, minus 9 times by 2 squared, so that's minus 9 times by 4, which is minus 36, plus 12 times by 2, which is 24, minus 1. So 16 minus 36 is minus 20, minus 20 plus 24 is plus 4, plus 4 minus 1 is 3, so we get 3 here. So that means that our second turning point is at 2, 3. So we have two turning points, one at 1, 4 and the other one at 2, 3.